Okay.
Jesus Christ,
Gå ta kaka på gjennom.
I'm starting now, but okay.
Hey guys.
That's free cake. You can't pass up free cake.
No, I'll pass on free cake.
Oh, okay.
Det var cake.
Se så går det når du er treg.
Du skylder meg kakestykket.
Det er mest å fylle topp.
You were the one that chose not to go and get it.
Stopp på kakestykket.
You had the time to go and get it.
Yeah. Okay, so I'll just start up again now. You know, more code. I thought sort of in this section we could discuss our graphics exam. We were incredibly lucky because my number one tip that people didn't necessarily listen to last year is always like if you have an exam which is completely open for a couple of days, like 2 or 3 days, and you know the topic, for instance graphics, and you're allowed to bring everything that you can into the exam, bring a fucking framework. Like, don't use your first day trying to get a triangle on screen. That should be, like, have something, it doesn't have to be fast, it doesn't have to be, or it should preferably be minimal and get the job done. Because we're super lucky in our exam, because this is our framework. It's, you know, a cube that rotates and it's full thumb lighting. And
Is it the cube that rotates?
yeah, the cube rotates. I think. No. It's too long since I've looked at this. We wrote this 2 days before the exam, and you can imagine our sort of happy surprise when we got our exam, and the exam was literally like make a Minecraft world, because we were finished. Like when we started the project, we just had to. We were supposed to be given a like height map file and create sort of a Minecraft world out of that. And by the first evening, all of us who had this framework were finished with like the main task. So, and we had 2 more days. So then you could, because the way, I'm not sure if you were doing it the same way, but the way we did it was like if you implement everything, then that's it says on the exam, then you get a C, and then you have to do extra stuff. To like push that up. Yeah. So in our case, we got 2 days of just going from like C to, you know, a better grade.
So you made points.
I didn't, but counted.
Okay.
Does audio count for the extra points?
Audio, of course. But
So yeah, so to do this, like
Volumetric files count?
most certainly, yes.
Even like it doesn't have. Even if it's not like, but also try to create something generic, something that just gets the job done.
Yeah.
For instance, it could be wise to make like a simple. If you're doing like a component system, then perhaps creating a component system where you have one graphics component that is a cube. Just have something like try to get at this place. I mean, now that you know that, you'll probably end up sort of like, yeah, now it's a circle Minecraft world, and then everything falls apart. But yeah, so that's how we did it. Sort of a quick overview over what we did. The way we structured our...
Can you increase the font size a bit for the stream?
Yeah.
So, cheers.
Like that?
Yeah, good.
For this, sort of just to quickly go through the architecture, we went for an object-oriented approach to this one, seeing as we didn't know what sort of object that would come, and I wasn't that experienced with component systems at that point. But we still went with a sort of flyweight pattern, which I think a bunch of you guys have already done. So who here stores all their OpenGL vertice data or like OpenGL related stuff, which shader programming you're going to use, etc., in each object? Is that so? When you create a new game object, you then also create a new sort of VBO and VAO and index buffer object, like on the graphics card, or do you just have the IP of those that you're going to use? What? When you create a new game object, when you create Pac-Man, Do you then create also all his vertices on the GPU so that if there's 2 Pac-Mans, there's double the amount of information on the GPU? Or do you just keep like the ID of the first one, like the GLU of the first one in your system, and say use that?
For the 4 goals, we actually use the same
Yeah.
BAO, BBO,
Yeah.
etc.
That's what you want to do. You know, but because there are some people that that sort of, if they have 100 ghosts, which are cubes, then they also have 100 cubes on the GPU, like single independent cubes. So in our case, what we did was that we created the stringly type system, which is we essentially every scene object had the name of their shader, their name of their mesh, and the name of the textures, and then they had a link to a reference to our render class, which you could call the nice function render, and then you would just pass along shade name, mesh name, and texture name, your model matrix, and your color, and then that would sort of update all of the OpenGL states, and have everything OpenGL related was in the renderer. We tried to avoid putting, we essentially avoided putting GL calls or GL functions anywhere else than the render function. So that sort of became our OpenGL interface.
Did you do UV maps?
No.
Like,
You have gotten further in graphics than we did.
we haven't made UV maps.
No, but in general, I think you have gotten farther in than we did. So yeah, I've just ignored the GSL owner sort of thing that's around the pointers. That's just me playing around with the system. But yeah, we created just an unordered map that was sort of ordered on strings, so a hash map that's ordered on strings for the shader programs, the meshes, the texture, etc. And then in our render function, we just looked up all of those and then bound them, etc. So, which created a relatively nice system for us to work with, because then we could just like focus just on the game logic mostly when we were doing our graphics exam. So yeah, I don't think there's that much really to show off in here. We also had sort of the screen with camera, etc. was also tied through the renderer. And for our shader programs, we also, yes?
Isn't the graphics exam like individual?
Yes.
Because you say
But-
hour all the time.
So
it sounds
yeah,
like you're
I'm talking in the class, but also, you're allowed to get help.
Are you?
I mean, it's a completely open exam.
So there's
Or
a
at
new
least it
rule
was
here
for
now.
us.
No Stack Overflow, no Discord. Because guys,
Yeah, me and Klaus made the framework together, and then I guess it was me, Klaus, Frederick, and Sebastian that worked together on the exam, or like sat together. And seeing as we all started with the same framework, essentially what we did that everyone got to the level where we would all get a C, and then we branched out and did a bunch of different stuff for like impressing factor, so that we didn't deliver the same product, but since we have the same,
I think it's reasonable to assume if you work together on your respective frameworks in your groups that you use that probably as a starting point anyway, right? Because you're acquainted with this, so it's no surprise that there will be a bit of a conceptual overlap, and perhaps even some sort of support in that direction. But you kind of want to do things independently, right? Asking someone for help or for a particular pointer in a particular direction doesn't mean that you take his or her code, right?
I mean, also what we did was that we would try to mark as much as possible the stuff that we got help on, etc. So I would say like, okay, for doing this, I got help from this and this person.
Very nice.
And then also, obviously, the reason for us being able to do this was that we had the oral exam with Simon afterwards, and
you will have
your penalty for sort of using a system that you didn't understand was way worse than sort of fucking something
Don't tell them.
So like, yeah, if you have no way of defending a piece of code that you've got help with, then don't take it in. Because I'm guessing you will probably also do that. It's worse to have code that functions, but you don't know why.
Exactly.
Than having code that doesn't function, but you have some sort of ideas.
Yeah.
How it should have functioned.
Yeah.
Well, even if you have a naive framework that does its job, but it's straightforward, no particular magic, but you can explain it because you did it. It's way better than having an overly complex framework that has high levels of abstractions and complex game patterns and whatever. And you have no clue what the heck is going on there. So.
We decided to encapsulate all of our different OpenGL stuff into a shader program, which we just had 2 shaders, so we would send in the paths in the constructor and then try to construct everything there, get out all the uniform address so that you can query it from the outside, and also be able to bind stuff, which is why sort of our rendering function just is everything. Just setting up everything is just like straight up statements for manipulating the state machine. However, so that was the framework, and then this is the result of that after the exam had passed. Luckily, our framework was easily hackable, so we managed to do this. I think my skybox is the best example of have the good thing of having a hackable framework, because that is literally like I was like, okay, I don't know how to do a proper skybox. I can hack it in 2 lines, and that's what I did. So essentially, what I did was I just changed the culling so that for the skybox and only the skybox, the culling is the other way, so that you draw the cube from the inside instead of culling it so that you can look out.
And then just taking a normal cube and scaling it up.
Yeah.
Nice.
We load maps from different files, etc. We had all the lighting and stuff in place. Our main issue was that when we ran this on the exam, which was sort of why we got a different challenge on the exam, seeing as we had a framework, it ran like shit. As in, like, our original implementation, the one we had the first evening, we probably ran at like 20 frames per second in the debug mode, and then in release we ran at 60 because, release. But still, it wasn't sort of acceptable not to hit 30 frames in the debug mode. So our rationale for the big way of fixing that was isolating what cubes needed to be drawn, etc. So as you can see, there's nothing being drawn on the inside here.
What if you destroy one?
I won't do that in this demo because this demo, it is possible, and then we just update the list of elements that are drawable. So on the GPU side, or sort of on the of stuff that's being drawn, we have 2 lists. One of stuff that should be drawn and one of stuff that shouldn't be. And if we destroy one cube, we just update the drawn list based on the newly generated.
Is that a light spike?
No.
Okay, nice. So every cube just, since everything is cubes, makes things sort of very easy. So you can just, every cube just check, well, am I neighboring to air? And if I'm not neighboring to air, then I am not being drawn.
Yeah, essentially. I wish I could show off the sort of deleting and stuff now. The problem is that this sort of is my next point, which is optimizing this, and my sort of optimized version of this actually crashes when you try to remove cubes, etc. Because I haven't gotten to the point of implementing that yet.
So how much performance boost did you get from not rendering stuff that is not visible?
Actually enough that we considered it sort of, we went up to 60 FPS on debug mode.
That's quite performance.
So for us, that was the main one that, or I think not 60, perhaps, no, I think we went up to like 38 or something, because we are doing it in, yeah.
Is the sand on top just depend on the height, or is that the data in the map file?
Everything is dependent on the height. So if you start adding blocks, then we have basically set up a height map of like, or sort of thresholds. So if you're over this height, then you have that in that texture. So yeah, the other thing that I did was, I'm not sure if that was really smart for performance. It might have been. Essentially, in the renderer, keep track of basically all the previous settings on the GPU. So sort of from the previous times that people called the render function, and then if there isn't anything, if that hasn't changed, then I don't update the sort of GPU either. So if you change the shader program, I check, or if you send in a when you send in a shader program, I check if that is the same as the previous one, and if it is, then I don't update the I don't say like GLU's program again. And the same with uniforms. I sort of compare the different uniforms and check if they need to be updated or not. However, you know, this still isn't that great for in terms of performance. We're using about 16 milliseconds was what we decided on to
6 milliseconds.
for 6 milliseconds.
Mm-hmm.
Yeah, for each iteration of the game loop, which you know works relatively well for this demo, but it sort of will break down if you add in more huge maps. And so not so long ago, I wanted to try optimize this. Do you have a question first, or?
Yeah, on the you were caching the GLU's program. Is every GL call, is that a context switch and are you actually moving data to the GPU, or?
From what I understand, yes, but not necessarily at the time of call. Like it's sort of asynchronous. This is from what I understand, and again, my graphics experience is sort of limited. But from what I understand, they essentially queue up your, or a lot of implementations queue up all your commands, and then they don't necessarily execute them before they are required to, because you don't want to like spend much time sending small bits of data when you can sort of queue it up and buffer it. As long as so that also what made it a bit hard to profile this. I found out. But yeah, the main reason was that at this point none of us really had that much experience with profiling. So you know that's a tip: get experience with profiling. Because we did a bunch of random optimizations that probably just made our code less readable, without knowing how much we got out of it. Because I want to sit down and try to see how fast I can get this to work. And I got some help from some other people, and we looked at the profiler, and we saw that we spent much time in the drivers, or sort of like the GPU drivers, or the GL drivers. We would like, and probably what we would like to do is reduce the amount of state changes that we're doing to the GPU and the amount of draw calls. So I don't know, you probably don't see it from here, but currently per frame we're doing 16,289 draw calls.
16,000?
16,000.
Yeah.
That's a lot.
Yeah, that's because we're drawing each cube individually, so we only have one cube on the GPU.
Still though, you're doing right under 160 frames per second.
Yeah. But we wanted, so this is currently 6 microseconds, so I wanted to change that, so I got a suggestion that, you know, try to, instead of sending each cube over, try to actually make sort of the map on your CPU first as a whole mesh, and then send it over. And
but how can you do that when you have different textures for the different parts of the mesh?
I can show that. So after doing that and finally getting it to work, it took some time. We're now down to like spending a couple of microseconds going around it. So we're talking like 100 factor improvements. So now it's already
the
16,000.
graph for the CPU is significantly low.
I never follow on these ones, if that's the one you're talking about. Yeah, I never read those. But yeah, so that's, you know, 100x improvement. And had we done that instead of creating the sort of list of drawable items on the day that we were doing like on our exam, then we probably wouldn't have to do any of the other optimizations at all to sort of get to an acceptable place. So we've gone from 16,289 draw calls to 2, which you know, yeah. And essentially what I did was that I created, in the mesh, I also take in all the, so we're doing a texture map sort of thing. So we get a texture atlas in, and then we figure out which texture we're supposed to use by just having an index. And the way I kept all those textures, sort of creating the same map of, creating the map of using the textures, was I essentially sent in all the texture indices were also
In the video.
in the video, and then in the shaders I did the sort of calculation of where are you supposed to be on the shader map.
Oh, that's not too bad. That's just pretty simple. Are you sending like the size of the texture sheet to the uniform, like the shaders, the uniform as well?
Yeah, the number of rows and columns, and then like even changing the textures is done pretty easily, and that doesn't really incur much of a performance improvement. So basically, what I'm doing now is that I'm just going through the offset of where you're supposed to start, seeing as we only use 4 and 4 textures. So that instead of like doing this texture row, then we do the next one, and I can like hold in the button for doing that.
So there's only 4 textures in the game?
Yeah.
Or that one?
Yeah, and then like even holding that button down and sort of like per frame, we're still going up to like just using 200 micro or a couple of microseconds still.
200 microseconds, yeah.
Yeah. So you know, do that.
Can you click
Go
one
on.
time?
Huh?
Can you click like this instead?
You're probably
Holding.
No, because like we iterate too fast, and our
Yeah, there's no buffering in it. Yeah.
no, yeah, and we weren't really happy with, so we were forced by Simon to use this sort of controller scheme that he had implemented that none of us really liked, because it wasn't how we were used to doing controllers. But
I mean, you can solve that by just having a timeout on the button input.
yeah, the problem is that if I don't remember wrong, that the input that we were handed out input system was cycle based, not time based.
What do you mean cycle based?
Like in it waits 100 frames at a timeout. So if you do more frames per second, then you know. I think that's what happened. That's because otherwise we wanted to do timeouts to do this properly.
Yeah.
Yes.
We used GLFW for our assignment too, and we also had a problem on Linux that it would just iterate too fast through the selection, like in the main menu.
Yeah.
And on Windows, I have the newest version of GLFW, like .2, while on Linux the standard library you install through apt-get is only 0.1, so it doesn't have the wait event.
So you can probably get an earlier. You can probably get a later version on the control. You just have to go and ask specifically for it.
Yeah, you need to compile it yourself. The way we fixed it, instead of just compiling it ourselves for the new library, we just had 2 states for each, but like if it was pressed and if the last, like previous frame, if it was pressed.
Yeah.
And then we just check if is it pressed now and the last frame also pressed, don't do anything. If the last frame was pressed and now it's released, the button is activated.
But then you need to let it go always.
Yeah.
Yeah. Yes.
Yeah. So bundling a lot of vertices in pure DVOs is a good thing. Yeah, pure dropouts. But so we are running into the problem where you can't fit all the vertices inside one buffer.
We have over 60, like we want to load models that are over 65,000.
Then create 2 and have half of them being the one.
Yeah, but
How do you link them?
I don't know.
I'm sorry, but how do we know how how many we can fit in? How can we check that?
You can probably query OpenGL for it.
I
Yeah.
think there is a function that
But with it, and that, my impression is that depends on also your hardware.
Yeah.
Yeah. So depending on your hardware, you split it up in like 4 or 2.
Yeah,
It
I
also
guess.
depends on your structure. If you have a lot of stuff in the VAO for every vertex, then you'll have space for less vertices.
Yeah. I couldn't find any good way to do it though. So
I'll also just quickly mention, because I didn't know about this function, but I don't know if anyone here has done mapping of buffers. So this is something I've really wanted that I've not seen before, that I finally found. Because apparently, like, I'm used to doing the GL buffer data type thingy when you create a buffer and then you give it the data. And then I thought, like, the only way of updating that was doing that again. Or the buffer data actually creates space, and so it allocates space and then potentially puts data into it. But apparently you can like get pointers to not necessarily directly to video RAM, because that is on another place. But sort of it acts like a pointer to video RAM, and then they do syncing for your screen. So you can just like buy the buffer, and then you can map it so that you can get a pointer to it, and then you have to specify what you're going to do with it. And then you can do regular pointer mapping on it. And then but you have to unmap it when you're finished. And that's really awesome, because suddenly you can do like regular pointer stuff, like memcopy. And that's how I do all the updating of all the indices. That's basically just like get out the buffer where all the texture indices are, and then just like copy from the other buffer I have all the new indices into that one.
Yeah.
Just be kind of nice to have a little something about that on the GitLab page for graphics, like wiki entrance or something.
Yeah, I probably should add that. Yes.
For the buffer, yeah. So exactly
Just so you get a void pointer out of that. And seeing as this is sort of not type safe in any way, you get more into the problem of you have to know exactly how many bytes you're dealing with. So just like so you're aware.
you get to the beginning of the buffer.
You get the pointer to the beginning of the buffer.
What's the difference between doing this and just having that as a uniform? Why not just have that as a uniform? That seems like a way too simple of a data type to send in a buffer.
That's the way I did it for setting up the all the different. I could probably have done it on the uniform, except that seeing as I'm having like 16,789 cubes, I'm not sure if it would be how I would transfer that over as a uniform.
But don't you just say what offset there is, right?
Yeah.
So you have the texture that's being loaded.
Yeah.
And then you have
but each cube has different offsets
in the
texture table. Yeah.
Yeah. What?
Because some are snow, and then some are rain, and then some are.
Yeah, but they're all offsetted. In your case, they're all offsetted horizontally, and changing the row is just saying, well, this variable that says what row we are on, or now, instead of 0, it is 0.25.
I don't have a variable that says which row we're on. I go like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then I mod myself back, so I'm not giving you the like X, Y sort of. Because in that case, yeah, I could probably have done something like that. I could still probably done it. It's just I'm not great at graphics, so I just went for this one because that one was the one that made most sense when I was doing this. Just.
So we are solving. I've been solving the same problem with GL buffer subdata.
Yeah.
How is that different from GL match buffer?
I don't remember. I think doing the mapping buffers, being able to give the sort of indication of what you're supposed to do might allow for some optimizations.
Yeah, okay.
I don't know. That's just like the one I saw that they showed off at the NVIDIA conference that I watched.
Yeah, I see that here you actually get a pointer on the CPU. Yeah. In GL buffer subdata, you don't get a pointer.
You don't get a pointer.
It's more like, but it solves the same problem.
Sure.
By not allocating a new buffer, you use the existing buffer.
Yeah, it solved that problem. Yeah.
Yeah, that's one.
Yeah.
So scaling up the project you have, well, now, what would be the first bottleneck you think? Like, say you would have increase the map size to a ridiculous amount.
Well, the main problem I see doing it this way is that I will get memory problems on that GPU after a while.
Run out of memory.
Because I'm allocating space for all the vertices. And if I then sort of add a map that is 40 times the size of what I'm doing now, I don't have enough memory necessarily on my GPU. Yes.
Would you then instead have to use that GeoDraw element instance?
I'm not sure. Like, I don't know.
And
I haven't done graphics really since I did my graphics course, so this is just me sort of like slowly getting back into it. And I didn't do that very well when I did it either. All those questions about like what could I have done instead would probably be answered by sure. Because I don't know. But my current plan, because I want to continue working on this, is try to find a way of having like blocks of memory that I sort of stream to instead of having something created. So that I like split the road, for instance, into 4 and then have those 4 as different blocks, different meshes, and then I update meshes to sort of dynamically load new content.
Right. So I think Minecraft does this in chunks.
Yeah,
So
that's what
it
I'm
does
thinking
every
of.
chunk in one mesh, and then it's very modular. You can have a certain number of chunks.
That's my plan. Right. So just sort of to get back here, just mention one thing. Unless there's more questions about the exam.
do you think this is the same reason why Minecraft Windows 10 edition is so much faster? Because they put everything into one protocol
I
instead
have
of
no clue.
It's C++.
Although I will say though, be careful about when you're doing profiling. Be perhaps a bit careful about what sort of profiling you're doing. If you're doing sampling based or instrumental profiling, because when we profiled this, we did instrument profiling, which I think basically which goes through and annotates all your functions, so that you can see exactly how much time you spend in each function, etc. Totally kills your performance, but you're not running it to test something, hopefully. In that case, you're sort of like, because we fell down like 12 frames, etc., or 2 frames per second when we were running in that mode. And one of the things that we found was that it gave us a bunch of data that wasn't entirely correct, saying as our, or it was obviously correct, there wasn't anything wrong with the profiler, it was our interpretation sort of got messed up because of some noise in the data, and that noise was, our code was instrumented, the OpenGL code was not. So we ran like massively slower in our code, but the OpenGL code, seeing as that wasn't being instrumented, that runs super fast. So we sort of get it, like it was hard to see that that was actually the bottleneck, because we would spend all the time on CPU instead. So like from our conclusion, we came to the conclusion that like the main problem here was the unordered map in the renderer. Because we saw that we were doing like string hashing. Every frame we were hashing the strings to find out which shader we were supposed to use and which mesh we were supposed to use, etc. And when we looked through this, we saw that like, oh shit, we're actually using like 40% of our time we are spending in std hash of string. So obviously the unordered map is the problem. And then after getting someone who actually knows what they were doing to look at it, they were like, no, your problem is that you're sending too much. You're like sending data, unnecessary data, too much to your GPU. And so just going on and change that, like seeing the unordered map now that's not a problem. So just be aware of that if you start doing profiling, that you actually get the data that you think you're getting. Because I mean, we were like, if we're struggling to do this Minecraft world at 30 frames per second, how the hell is it possible to do like GTA at 60 frames per second? Like that shouldn't be physically possible. Like what sort of magic are they doing if we're struggling to get to the 30 FPS on this simple Minecraft world? The next thing is, I don't have an example for that, yes?
Yeah, on the map thing.
Yeah.
So we are having, in our engine now, we're having a system where we have both strings and IDs.
Yeah.
So we use the strings for like easy things, but in the render hot code, we use the IDs.
Yeah.
Because we assume that they are much faster to look up.
They are much faster to look up.
Yeah.
Yeah, and
But we haven't tested that, so it's just an assumption. But
No,
are
but
we
that's
correct?
an assumption that it probably is correct.
Yeah.
Especially if you're doing like direct indexing,
Yeah.
because
Yeah,
then
we
you're
do
also
that.
like it's O1 and it's
Yeah.
Because
no hashing.
only when the IDs could have changed, we look up the strings again to check that the IDs are still correct.
Yeah.
Yeah, because the strings are always pointing to the same thing, but
Yeah.
the IDs might change
Right.
if we resize. So we just, every time we resize the buffer, we rehash,
Yeah.
sort of.
One thing that you
Yeah.
can do, which is a pretty one way that I like doing this, is that you have sort of if I want to share a resource with you, I give you one ID, and then I have sort of a two-dimensional lookup, so that this ID maps into here, which maps into here in my like resource array or whatever, because then you get an ID that is completely independent, and
Yeah, so you have an ID array,
yeah.
which gets like rehashed
Yeah,
once
you
the actual buffer updates.
what you do is that you doing it this way, you can say that like the ID never changes in this table, but then you can move as much as you want around in this one as long as you update this one.
Yeah.
Because then you can give something that is completely independent of your underlying.
That's what we want to do.
Yeah.
So,
And then you can do a bunch of things to make that go fast as well. So you can spend like, if you don't care about buffer overflows, or not buffer overflows, if you don't care about integer overflows, you can do stuff like say that instead of, if this is 32-bit, then you can spend like the first 16-bit is the ID, and then the second is your index into this one. So that you can sort of even faster go and look up there, or do like generational stuff, so that you have an ID, which half is the ID, and the other half is when that ID was generated. So that if we've moved stuff in this array, then you can say that, okay, I see that I've changed stuff since the last time, so this ID isn't valid anymore, and now I have to look it up again or something. Yeah.
So what were this 2D array of IDs for? Say if you share a resource, so say one component or one something.
shader, for example.
Yeah, wants to share a resource, say for example texture. You would have a two-dimensional array.
No, it's not a two-dimensional array. You have two arrays.
Ah. Okay.
One array
Like-
also indexes into the.
Like now we have another map with strings. So we say we want to use shader, the default shader, which has actually string.
Yeah.
But now you just have IDs
Yeah.
instead, so it's faster because you don't use strings.
But that only supports sharing one resource, because in that specific indice, like in the topmost array, you can only have one number, and that number will correspond to one resource. Yeah.
Essentially, yes.
So
You can have many pointing to the same
so then you would
resource.
have
Yeah, but why would you have that?
Or the other way.
You would rather say that I want to use, I allocate one resource from that, and then I distribute that number however I want.
So it's one-to-one mapping, though.
Yeah.
No, it can still be a one-to-many mapping. It's just that it's a one-to-one in there.
Yeah, but say a shader needs two textures.
Yeah.
Then you would have the shader ID, and that's in the topmost array, right? That would be, for example, 4.
Yeah.
And then in indice number 4, there would be a number that corresponds to a texture ID.
Yeah.
The only problem is when you need the other texture, you don't have space for another ID in the topmost array. So you'd have to have a 2-dimensional or
no, because what you're doing is that I say I want to store one shader, or I want to store one texture.
Yeah.
Or I want to store 2 textures. That's 2 different resources, you know. So this is text 1, and then this is text 2.
Oh.
Or the IDs of them, obviously the sort of their GPU representation, so they're like GLU in. That's down here. You know, that's their IDs. They're like OpenGL IDs. That's the references down there. And if you need 2 of them, then you have 2 IDs. And then just say, I want to use texture 1, and then you get sort of that ID back to you, so you can say GL use texture with that ID, and then if you, or like update the uniform corresponding to that, and when you want the next one, you say, I also want, oh, by the way, I also want texture 2, and then it goes and looks at that and gives you that back, and then you set the texture to being that.
Yeah. Because the problem is, in your game code, you don't want to care about if it changes. You want the same ID all the time, and then you allow it to change under
under the hood. Yeah. Sharing pointers obviously is also one of the ways of doing that, but then you can't modify the underlying memory. So the last thing, unless there's even more questions, is this one I don't have an example of, but this I've seen this been talked about before. Because I did a short talk on our AII last time, of like you have your constructor and then you have your destructor, or destructor. You can do a lot of fun things about that. That's actually a quite nifty mechanism that we know that when you get to the end of scope, you pop something, you know, you pop stuff off the stack. So what you can sort of use that, seeing as OpenGL is a state machine, you can do some cool things about with that. So for instance, what you can do is that you can create sort of a class or some structure that in the constructor you push a new state onto the stack. So you get the old state of the current state of the OpenGL. So you get like which program are we running now, and any sort of state that you're thinking of changing. You read all those from the GPU, and then you sort of save them away or store them as members of a class or something. And then you do all your work, so you set up your new GL program and your new textures or whatever. And then in the destructor, you go back to setting it back to the previous settings, sort of in this class. Because then if you have temporary changes or you want to get back to the previous state, then you can just like simply create this structure on your stack, and then as soon as that goes out the function scope, you will be back to your previous OpenGL settings. Did that make sense, or was that a way to sort of confusing?
What do you mean about settings?
So it made sense, but why?
One of the reasons I see for doing that, if you're doing something temporary in the system and you don't really want to sort of go back to the previous setting. But one thing I've thought that you can actually do with it, first of all, it's a relatively clean way to do it, or to do the state management. So if you're not necessarily sure of how the states are interacting, etc., then that's a good way of getting back. But the thing that I've thought about doing with it, that I want to sort of test out, because I haven't tried this that much yet, is in debug builds, have it so that in the structure you actually sort of like turn off all your OpenGL states again, to ensure that in like release builds, etc., I'm not relying on previously set OpenGL settings. So that I always ensure that when I'm trying something, I'm actually setting all the new variables. I'm not relying on sort of the old ones, because then you can, in debug builds, just set everything to be like null or empty or whatever, and then you will be told that you know, that something has gone wrong when you're doing your error checking because you don't have a valid program or whatever.
You don't get
And then,
positives.
yeah, and then in your sort of, the cool thing you can do then is that in the destructor of those sort of state wrappers, you can just say that if you're running in a debug build, then you do all of that zeroing out stuff to ensure that you're not relying on previous values. But in the release build, you're not doing that. So that in the release build, you're just setting the new sort of values that you need. Because then you sort of, in debug, you can get all the extra information that you're doing this correctly. But in the release mode, you turn off all that error checking.
You want speed.
Yeah. And that's sort of like doing that with constructors is with constructors and destructors is a pretty clean way of doing it. Because you don't necessarily see, you probably won't see that sort of dirting up your implementation when you're actually doing it, because it's just like you're creating a struct and then later it might be popped up and reset everything.
Where does that framework come into this?
Huh?
RAI?
Yes, that's using the RAI mechanism, the resource
So
acquisition.
instead of doing it in your destructor and constructor, you just...
No,
use that.
the RAI is a fancy name for constructor and destructor.
Yeah, it's not a
Nobody
framework.
knows that.
No, it's not the framework. I can't remember saying framework, it might be the...
No, maybe I
yeah.
just assumed it.
Yeah, no,
Yeah.
it's not that, it's...
Yeah, you should explain what
Yeah,
RII is.
yeah, but now you all know it's constructors and destructors.
It's just the
It's a bit
C++
more than that,
way
yeah.
of saying that you construct something in the beginning of a scope and destruct it.
It's a C++ way of saying that when you construct something, you also acquire resources.
Yeah.
So that when you're creating your if stream and you have that as a file, so like you give that a file path when you create it. If it's been created, you know that it's functioning well, because otherwise it would like have thrown an exception, etc.
That you don't have to run an init
Yeah.
function after you have constructed it.
Yeah, and then
So
you don't have to
actually
care about the
load the
destruction.
file.
Yeah. And then you don't actually have to care about destruction either, because that happens with destruction.
Close the file.
Yeah. So yeah, sort of to wrap up, last sort of exam tips. Build a framework. I've said that a couple of times now, but I don't think I can say it enough. Build frameworks. Build frameworks that are easily hackable. Just have some tips, because we hacked the shit out of our framework, and that's probably why it went so well. Obviously, hack it. Make it work. Don't make it super generalized until you can. This is especially true on the exam. You probably don't need stuff to be generalized on the exam. You need it to work. By trying to make them really generalized, you're just creating problems for yourself. So get it to work first, and then generalize it if you have to. Like, we talk about premature optimization. There's the other part of that, which is like, don't do premature abstraction.
Don't make some stuff modular and things with good code quality. Like, don't write stuff that is like complete garbage. But then again, like, don't struggle to make this modular and ready for its like scalability and super like, probably make it a little bit readable, but don't spend too much time on that.
And lastly, do use RenderDoc and all the other debugging tools, and learn to use them before the exam. Because you had a talk on that, didn't you?
Well, after some inspiration on your part, we had CodeXL and RenderDoc. So.
Right. Like, learn how to actually use those, especially RenderDoc, because you can actually sort of move around in the camera in the frame buffer space. So if you suddenly have stuff that aren't appearing on screen, like I had a problem that my positions wasn't calculating properly, so stuff always ended up behind the camera, then like I could go into RenderDoc and sort of look around and look at all the values, and sometimes also see that, oh, this sort of mesh is actually off camera, but I couldn't see that normally because it will always move around. So yeah, use all those tools.
So we should use Windows.
You can use RenderDoc on Linux.
Yeah.
So I have to bring my desktop computer after school.
Or you can also use it on Mac, probably. No? Well, then you can use the AMD in D1.
Code Excel.
Yeah.
Don't know.
I think maybe we're late.
Yeah.
bring my
So
desk.
I probably need to intervene because I'm seemingly responsible for the next lecture.
Yeah.
Do you
So
recommend
thank
being
you very
at
much.
school during the exam?
Yeah. Yeah, everyone just like hog the game lab and sits there and work.
Oh, we do it anyway.
And get help from each other.
And is it okay to throw everyone else out of the game lab during the exam?
Yeah, that's
we can make a sign on the door, so it's
as long as it's not a Wednesday, then it's okay.
it will be.
Even club.
Sure. Well, you can
And you?
probably also me, but you can decide how smart is it to throw out Glenn, you know, the guy who's best at graphics.
Yeah.
From the game lab.